Hello there everyone, happy holidays and welcome to this Touch Designer tutorial. In this tutorial we're going to take an audio input, analyze the spectrum and then map that in 3D using pops. And this is actually a very simple and easy to build network that has a lot of visual impact and modification ability. In a lot of ways, this is very similar to the method that we would have used in TOPS to take our audio data, visualize that as a string of pixels, and then use a feedback loop to have that expanding and evolving over time. My introduction to using Touch Designer was really through the fact that I was doing a lot of audio visual work. So I spent quite a lot of time making these types of effects early on. And I actually have a repository from way before I was doing YouTube stuff that you can access, and I'll link this in the project description here. But I have a whole series of projects on spectrum visualizers, and an early tutorial that inspired me, which you can also go and look at. I'm not quite sure this is the right one, but I know that Electronaut has a audio analysis video from quite early on. That was one of the ones I looked at when I was getting started. Anyway, you can go and check all this stuff out, but we're going to go back to 3D land and tops because we can do a lot of stuff. I'm going to go ahead and delete this section because I'm using a couple of inputs to capture my audio for the video. I'm not going to start completely from scratch today, but this is basically a blank project. Also going to clean this up and we'll come back to that later. So the first thing that you're going to need is some kind of audio device in. We can create this from the chop menu and we want audio device in. I already have one, and right now my outputs are muted because I'm recording to the video. I don't want to hear my voice in my ears. If I hit P, we can bring up the parameters, and what we have here is basically the list of all the inputs that we might want to use. I'm using my inbuilt microphone today, but you can use whatever input you like. And from here, I'm going to bring this out into an audio spectrum. And the audio spectrum is going to give me a weighted spectrum analysis of all the frequencies in that audio that's coming in. And what we have in this FFT size here is basically a control of how granular that is. So we can see here we have quite a lot of detail. We're at 8,192 for our FFT size. But if I take it way down to say 256, we can see that that spectrum becomes a lot less precise. And the larger the FFT size, the more detailed our spectrum analysis is going to be. And I would suggest with going something fairly high, depending on what your computer can handle. This effect will work with any value of input, but it's going to look better if you have something that has a sort of detailed spectrum. I'm going to go with the highest value, but anything from 2048 upwards should be fine in terms of your visual aesthetic. I'm going to connect this into a null, which will be the end of my chain, and I want to check how many samples are part of that stream of data right now. So we have 22,050 samples, and because we're going to be copying this quite a lot of times, I'm actually going to add in a stretch in between. You could also use a resample. And in the stretch, I'm going to say absolute. The start will be 0 and the end will be 1,000. So now that has been squished down to 1,000 samples. So that's going to be a little bit more manageable for me when I start copying stuff. Okay. What I want to do now is I want to transform this data into pop information. And what I'm going to do is I'm going to do chop2. Just tidy that up a little bit. And we can see that some of that data is translating right now in terms of giving that line a length. What I want to do is I want to remove this attribute scope P. We'll keep our line like this. And what I'll do is I'll select chan1 from our input channel scope. And I'm going to call it spectrum. And that's going to be the attribute that we pass our data along in. I'm going to bring this into a math mix. I'm going to create a way of scaling that value. So I'll do spectrum as scope A, and for now I'll do 1 as scope B. So basically spectrum times 1 will be exactly the same value, but if we times by 2 we can double it, times by 0.5 we can halve it. So it's just a way of controlling the intensity of how much we're applying this effect. And then I'll add another operation, A plus B. I'll use P dot Y plus spectrum. And now we should see that our spectrum is feeding into our pop, which is awesome. And we can obviously move this up so we can have a much more intense level of input, or we can have it kind of lower level down. And I'm going to keep it just multiplied by 1 for the time being. So now we have our spectrum data visualized in a pop, but we just have one line. So what we actually want to do is we want to stretch this out and have the history of that spectrum. In our minds, we might think that bringing this out into a copy would solve this for us. In this case, let's do just 20 copies. We'll translate very smallly on the Z. But what we're finding is we're copying the same thing. So it's not going to be a spectrum over time. It's just going to be the same spectrum 20 times. To create this effect with the evolving history of spectrum, I'm going to use one of my favorite techniques in Touch Designer, which is a feedback loop. I'm going to bring this out into a feedback. In the feedback, I'm going to turn on this memory limit just to keep us sort of safe of overloading our system. And I'm going to put the multiplier at 1000. I'm going to drag this into a null. That's the end of our chain, so we can call it end FB. And what's really going to be doing the heavy lifting here in terms of creating that trail is adding in this transform and adding in this merge. So we want to put our input that's before the feedback, so in this case the math mix, into our merge. And what this means is that we're going to be combining whatever's in the feedback loop with a continuously updating input. So this means that the data that we're currently creating, so this speech that we can see, is going to be fed into that system and is going to be influencing that feedback. One more thing that I'm going to do just at the end of my chain here is I'm going to add in a delete. And the way I'm going to work with delete is I'm going to go into bounding. And again, just like setting that memory limit, this is to make sure that we don't go anywhere too crazy. So I'm going to say, let's just do 3, 3, 3 and turn invert off. We can rehome if we lose our visual. Okay, let's drag this FB onto our feedback and see what happens. Okay, so we can see that we have a lot of stuff right here that's just adding to itself, but we're not moving in time. And what we want to do here is go to our translate and just add a very small increment right there. So very cool. We can see that our speech is being manipulated by that feedback loop now. I'm going to split my screen. So I'm going to do Alt left square bracket and do Alt 3 to visualize my 3D space. I'm just going to click this blue display tab to see that. So now we have a spectrum that we can work with in 3D. This transform is sort of arbitrary in terms of basically the displacement that we do. So we could do minus 0.2 on this one, and then we're going to see that it's going to go down. Or you could do multiple, and then you get something that's kind of going sideways. So really, this is a method that you can sort of play with to decide what makes sense for you, we can see that delete is preventing anything from going beyond that point, which is really handy because it just means that we're not going to sort of scale out of control and have something that is going to crash our system. A fun thing to do could be to animate some of these parameters. I'm going to add in a little automation here. So abs time.seconds in a math.sin. And obviously we don't want to go quite as large from -1 to 1. So we're going to do a multiplication by 0.01. Speed up that sign. So then we have something that is warping around. You could also just add in an LFO instead. That might be a little bit more easy to implement. Basically, we just want something that's kind of shifting over time and maybe not as fast as that. Let's turn that frequency way down. And that amplitude down as well. We want very, very small values for this because obviously it's a feedback loop, so it's incrementing multiple times per second. Another thing that we can do to give us some control is we can add in a keyboard in to reset that feedback loop. It's actually over here, isn't it? Link that to our feedbacks reset. So when I press the 1 key, it's going to reset, which is great. Okay, for now, I'm going to remove this LFO. I'm going to set this back to just being a regular sort of translation, just moving in this Z plane. So we have our spectrum coming in and we're affecting it, and we can see that history. If you want to reverse it, you just reverse that translation. I'll keep it sort of moving away. And something that I find kind of fun to do here is I like to add in a line smooth in my chain. And what the line smooth is going to do is smooth out that information. So we can see here that it's maybe operating a little bit too much. So let's turn down that effect. As we go, we'll see that the line softens. If it's down really low, we'll see it softens not that much. But if we put it down to sort of a nice amount, we'll see that the line sort of gets kind of softer over time, which I think is just a nice effect that sort of makes it feel a little bit more organic. If we do go for a larger effect size, what we can see is that everything sort of gets pulled into this triangular point. And a way of fixing that is just to select endpoints fixed. And this means that no matter how much smoothing you're applying, you're going to have a line that is held on the endpoints between the points it's actually meant to be held between. Let's bring this down. And in this case, what you can also do is start thinking about amping up that spectrum. So now we have something that is going to be a little bit more aggressive in terms of that first input. And this really is the core effect. This is the point where you can start playing around, adding in different functions, making this your own. One thing I'll do right here is I'm going to plug in an audio track instead of my voice. Probably want to plug it in to both places. And I'll just give you a little bit of that track just so you can hear it. Because you don't need to hear the track all the time. It's quite lively here. I've really ramped those numbers. So let's turn that back to something like 0.5. For something that's not voice, I generally think it's better to have a lower value because generally a track is going to be mixed louder than how loudly I speak. Again, this is all something that you can sort of play around with. So we have the core effect. And what you can really do now to play with this is you can add things into your feedback loop to see how those impact that system, or you can add sort of post-production elements after that feedback loop. For me, I like to bring in this component that I've made that's sort of a GLSL wrapper that turns things into a sphere or a plane. So we have this sort of plane here, which I really like. We can control things like the center radius of that. Let's see if there's any sound coming in at this point. Yeah, there's some sound going in. But what you can also think about is breaking this down. So rather than having this be line strips, convert it into points. And then you can work with those points and sort of think about them as like a point cloud or something you can manipulate. I kind of really like this type of patterning that we get right here. But yes, this is really something that you can play with and experiment with. I'm not going to go into a render network for this, but that's also an area that you can have a lot of fun with in terms of kind of texturing and coloring and kind of sizing those lines. Thank you so much for watching. I hope you've enjoyed learning about this audio spectrum effect today. And stay tuned for more tutorials in 2026. We'll see if I put out anything more this year, but it's been a pleasure and happy holidays.